Okay, let's start the next talk by Adrian Riesco about the towards Maude framework for the analysis of smart contract. This is work in progress. Please start, Adrian.
Thank you very much, Keisuke. So as Keisuke said, it's a work in progress, so it will be a short talk. I'll try to make it in 10 minutes. So the motivation of this work is just because blockchain technologies have gained popularity on the last years, and this is mainly because of their distributed nature. That is, if you have a high enough number of users or copies of your data, it becomes unlikely to modify the information because you will need more than half of the users to do it. So it makes the data stored in the blockchain independent of third parties and immutable in a way. And in particular, we're interested on new blocks that are periodically added to the blockchain. Because once a block is added to the blockchain, the information on that block is confirmed and it becomes immutable. So it's not impossible, but expensive to modify it. On the other hand, and we are interested in this, we have smart contracts. We are just programs that state that something happened if the conditions hold. For example, if you are in charge of a crowdfunding platform and you are the one selling things, you want the money to go to you if the goal is reached. But if you are a user that is going to pay, you want to pay only if the goal is reached, and otherwise you do not want to be charged. So the point here is that you need to trust someone, to trust the person in charge of the crowdfunding or the organizer or the platform. And what we want to do with smart contracts is you to trust in this technology, which will make things faster and cheaper and where third parties are not required. However, we have problems with smart contracts. One of them is practical, and it's that if they are contracts, you need people to understand them. But these are programs, and normal people is not used to code, so they might not understand what a program means. And you need someone to translate it into natural language, and then you need to trust the translator instead of the third party you needed before. On the other hand, you have immutability, which was a feature of the blockchain, and it's very good, but it's a problem when you put a buggy smart contract into the blockchain because you cannot modify it or you have to pay to do it. So in this setting, it's interesting to analyze smart contracts just to verify that they have some properties that mainly are that they do what they are expected to do in the given resource bounds. But if you have many different smart contracts, some of them easier so people can understand them more easily, and some of them are more complicated, maybe because programmers want to use some particular features. It will be also interesting to translate from complicated smart contracts programs into intermediate level programs. On the other hand, and as Francisco Duran explained, Maude is a high-performance logical framework where the semantics of other programming languages can be specified and analyzed. Then Maude specifications correspond to which is a logic of change that extends an equational logic. In the Maude case, this equational logic is membership equational logic that allows the statement of membership axioms characterizing the elements of a sort. And this logic is extended in rewriting logic by rewrite rules that stand for transitions in a concurrent system, and of course can be non-deterministic. An interesting point of rewriting logic, and obviously of Maude, is that rewriting logic is reflective and it can be interpreted in terms of itself. This feature is implemented in Maude by means of a meta-level module, which allows us to reason about the semantics of the languages being specified in Maude. Moreover, the semantics specified in Maude are executable. So once you specify the semantics of a programming language, you get an interpreter for free. So it's useful for fast prototyping. And moreover, if you want to analyze semantics or even the programs written in the semantics specified in Maude, you have several analysis and execution tools, including an LTL model checker, symbolic execution by narrowing, and some others. So in this work, we propose a Maude framework for parsing, executing, and analyzing smart contracts. For the time being, we forget about the interaction with the blockchain. And note that we have two different stages. One is the parsing and execution one that need to be particular to each programming language, because obviously the syntax or the grammar of each programming language is different. But then we could do an analysis stage that, using meta-level capabilities of Maude, can be implemented in a general way. So in the next slides, I will give you the rough idea of how to do this for a particular smart contract language, which is Scila. And this is not a random language. We decided to start with this one because Scila was designed as a intermediate level smart contract language. So you can take other languages which are higher level and translate them into Scila. Not all the features, because Scila is not Turing complete, but it's easier to reason than in other paradigms like bytecode. So first we need to define a grammar, and this is very simple in Maude because you just need to take the grammar for each non-terminal symbol. You define a sort. You might define subsorts with the relation between sorts, and then for each production rule, you have an operator where underscores are placeholders and indicate that terms of the appropriate sorts go there, and then you generate something of the appropriate sort. So once you have the grammar, where you are supposed to take a real smart contract like this one, which is the hello, the simplest smart contract available in Scila, just setting hello to some event and parse it in Maude. However, if you look here, for example, we have some keywords that start with an underscore, which is Maude predefined syntax for placeholders. So besides the tokenizer state, we need a pre-parse state that prepares the input for parsing in Maude. On the other hand, we are going to handle all these infrastructure as Maude objects, where we have our smart contract in Maude object here, and where we have a partial function mapping programming language identifiers into grammars. This is a meta-level module in Maude, including the grammar of the language. So you can, we only have this one in this example, but we could have many of them. And we have the current language here to know what is going on. And then just using these ideas, you will have this rule here that is in charge of parsing the input. So assume you have the input in this attribute read, then you can use metaparse with the input obtained from tokenizing, pre-parsing it, and then just metaparse takes the partial function PM, which is the grammars for the modules, takes the current language and takes the corresponding grammar and parses these tokens here to obtain T, which is a meta-represented term standing for the smart contract. Once we have terms standing for contracts, we can analyze them in the same way independently of the smart contract language. And to do so, we use Maude theories, which state some things that modules are supposed to hold. So for example, we have here code for looking for dev code, that is variables that are defined but are not used later. And we have the operators standing for functions, for example, or the sorts for variables, just to pick them up. Using this theory, we can define a parameterized module where we just take this this term here with operator q. If this q is part of the functions, then we get the variables that are being used, the variables that are being defined, and just using this difference operator here, we return for this function the variables that are being defined but not used. And this is completely independent of the original programming language. So these operators are later instantiated depending of the particular programming language. And in this way, we can just do it for all programming languages we want. And in fact, this analysis is a static analysis, and it's very simple, but we found some dead code in the examples in the official Scylla webpage. So concluding, we have a parameterized framework for parsing, analyzing, and executing smart contracts. I had no time for showing you the revised rules for executing contracts, but they are standard in a way. Some parts are language specific and the analyses are general. And we are interested in execution via translation. This is work in progress. Only Scylla has been integrated thus far. So we are interested on integrating more programming languages on the framework, checking new analysis, checking that the current analysis works in other languages, and defining transformation possibly from other languages to Scylla, which, as I said, is at the intermediate languages. Thank you very much.
So, is there any question or comments? So, we have currently no. Okay, so. Any question? No? So actually, I am not familiar with such a smart contract, but I have a question. Are there any the existing formalism for such smart contracts? Can you apply the technique to the framework?
Sorry, I couldn't listen the whole question.
Okay. I'm not sure because I'm not familiar with this area, but I'm interested in the formalization of smart contract. Are there any existing work which can be applied to your work or
Well, there is the K framework, which is a framework for the definition of semantics, which initially was made in Maude, but now it's implemented in Java, I think. They have some analysis, and in fact, they have a company for verifying properties on smart contracts, but they focus on bytecode. So these languages can be parsed into bytecode, and then you can analyze it. But we wanted to verify something that we understand, because you lose what's going on when you get to bytecode. So we wanted to analyze the smart contracts as they are.
I see. Interesting. Any other question or comments from the audience? Okay, so let's thank Adrian again.
Thank you very much.
Okay, so this is the end of the WPTE 2021. We expected that the next edition of this workshop will be held in the next year, co-located with FSCD again, if possible. Thank you for all the presenters, attendees, and FSCD organizers. Adrian, do you have any message from you? If not, that's fine.
Everyone for their work, and hope to see you next year.
Yeah. Okay. So see you the next year's next WPT. Thank you for.
Thank you.
Okay. Thank you.